Now, one benefit of putting our data into a histogram is it allows us an opportunity to describe the data. This is going to be really our first description of data. So we call this a distribution of data. Okay, we have a distribution of data. Now, if when we create a histogram, if all of the bars are approximately the same height, we call that a uniform distribution. Okay, so what does uniform mean? Uniform means that everything's about the same, right? So all of the frequencies for our classes are approximately the same if we have a uniform distribution. Now, we might also have a distribution that has a shape such as this. So in this case, we have like the tallest bar in the middle. And then as you go to the left, the bars get shorter. And as you go to the right, the bars get shorter. You can kind of see a symmetry about it. And so again, if it starts low, goes high, goes back down low like this, we call that a bell-shaped distribution. Now it also has to be symmetric. So it starts low, goes high, goes back down to low, and it's relatively symmetric. That is a bell-shaped distribution. Now sometimes we might get a distribution that looks like this. So in this case, the taller bars are on the left, and then we have a bunch of short bars over on the right-hand side. If that happens, we say we have a skewed right distribution. So we call this over here on the right, we call that like a tail. So we have a tail of a few large values, and that makes this a skewed right distribution. Likewise, if most of the tall bars are on the right side and we have a tail of small bars on the left side, we call that skewed left. So we often are going to want to look at our distribution and see if we can describe it as uniform, bell-shaped, skewed right, or skewed left. I do want to explain why it's called skewed right and why it's called skewed left. A lot of times people get these two backwards. And the way to remember and not get it backwards is you're looking for where the tail is. If the tail's on the right side, it's skewed right. If the tail's on the left side, it's skewed left. If you have tails on both sides, it's probably bell-shaped. So if I have a bell-shaped distribution, if I calculate the average is going to be somewhere here in the middle. Even if I have a uniform distribution, if I calculate the average is going to be somewhere here in the middle. So like around in there somewhere. If I have a skewed distribution, what happens is this. Most of these data values are in this, like if you're looking at this graph, most of the data values are like in the 0 to 50 range. So if I were to find the average, if I didn't have that tail, if I were to find the average would be maybe somewhere around here. But what this tail is indicating is that I've got a few large values. And so when I average in those few large values, those few large values are going to pull the average up. It's going to pull the average to the right, which is why we call this a skewed right distribution. That tail is indicating, again, a few large values, which is going to skew the mean, skew the average to the right. And then I could make the same argument about the left. So most of these data values are from like 60 to 160, right? So if I averaged, I should get somewhere around in here maybe. But because I've got these few small values, that's going to pull the average down. It's going to pull it to the left. So that's why it's called skewed left. So what about this? If you had to describe this as uniform, bell-shaped, skewed right, or skewed left, here's the problem with these descriptions. Sometimes it's not completely clear. And this is kind of a it's kind of a, I'm not absolutely positive what I would call this, because it's kind of, it's definitely not got, I mean, like the bell shape, right? You have the tall bar in the middle and then it kind of tapers off on each side. Well, we have this tall bar, it's not exactly in the middle and it doesn't exactly taper off on each side. So I'm not sure that I would call it bell shaped, but of the four choices, that's probably the best description. It's certainly not uniform. I don't have a tail exactly. So of these four choices, bell shape's probably the best of those choices, but I'm not thrilled with that choice because it's not exactly bell shaped. What's actually going on in this particular graph is another option that we'll talk about later on. It's possible we can have data that does this kind of thing. So like on this kind of thing, we have like two bunches. You see that? Because you kind of got a bell shape there, and then you kind of got another bell shape there. So when that happened, that's called bimodal. Bimodal, bi means two, and it's like you got two groupings. And that maybe is what we have going on here. We might have more of a bimodal scenario, two groupings that's happening. Now, generally, we're not going to want to do these things by hand. And the reason is because it just takes a long time, and we have technology that can do it for us. And so we're going to do that. So I have given you instructions here. I just pulled these from the textbook. This is instructions on how you can use your TI calculator to draw histograms. And then I've also given you instructions for StatCrunch. And these instructions tell you both how you can make a frequency and relative frequency distribution in StatCrunch and how you can create a histogram in StatCrunch. So I'm going to use this data right here, and I want to show you how to use your calculator first and then StatCrunch to work these problems. So look at this data. Cigarette tax rates. The table shows the tax in dollars on a pack of cigarettes in each of the 50 states and Washington, D.C. as of January of 2015. So if you look through this set of data, again, these are the tax rates on a pack of cigarettes. So I don't know which state, but one state charges 42.5 cents taxes on a pack of cigarettes. Another state charges $2 in taxes on a pack of cigarettes. Another one charges $2 as well. Another one charges $1.15, and so on, 87 cents and 84 cents, and so on and so on and so on. Now there are 51 data values here because in addition to the 50 states, we're also including Washington, D.C. So 51 data values here. Now, here's what we're supposed to do. With the first class having a lower class limit of 0 and a class width of 50 cents, construct a frequency distribution, construct a relative frequency distribution, construct a frequency histogram of the data. I have a typo there. I just noticed I got an X in there. Construct a frequency histogram of the data, construct a relative frequency histogram of the data, and describe the shape of the distribution. So again, uniform, bell-shaped, skewed left, skewed right. We're going to make that description, or possibly even a bimodal. Now, unlike the previous example, in this problem, we've been told what to use for the lower limit of the first class. It says use 0 as the lower limit of the first class and use a class width of 50 cents. So now again, I don't really want to do this by hand, but I'm going to write my answer out by hand, at least in part of it. So I'm going to look at my classes. So again, if I start my first class at 0, and if I use a class width of 50 cents, then if I take 0 plus 50 cents, that's going to be where the second class starts, which means the first class is going to stop at 49 cents. Now I say 49 cents, but technically it's anything before 50 cents. So like I noticed, like this has a 1/2 cent tax in there. So if we happen to have something like right there, there's 99.5. So that would actually go with like 99 cents. If I add 50 cents again, that's going to be $1. So this is going to end at 99 cents. Again, really just before $1. If I add 50 cents again, $1.50. So this is going to end at $1.49, or really just before $1.50. $2, so $1.99. $2.50, so $2.49, and so on. Now our the largest tax is right here, $4.35. The smallest tax, incidentally, is, I saw that somewhere. There's 30 cents right here. Is there anything below 30 cents? I think 30 cents is the lowest one. Anyway, we're not really going to do this by hand, but my point is that that's going to go in the first class, and I'm going to need a class for the 435 to go into. So I need to keep going until I get there. So like this is going to be $3, and this is going to end at $2.99, $3.50, so $3.49, $4, so $3.99, and then this is going to go to $4.49. The next class would start at $4.50, but we don't need another class because of the 435 is going to go in that class. So I figured that out. Now I'm going to let my calculator do the rest for me. So again, I've given you instructions here on how to use your calculator for this kind of work. The calculator will not directly tell you what the frequency distribution is or the relative frequency distribution is, but you can use the calculator to figure it out. The first thing that we have to do is we have to enter the data into the calculator. And we haven't had to do that before, so I want to show you how to do that really quickly. Generally, when we're dealing with data, we're going to go to this button right here, the Stat button. So I'm pressing that. When you press the Stat button, the screen that comes up shows 3 different menus. We have an Edit menu, a Calc menu, and a Test menu. Edit menu we're going to use to edit data in the calculator. So we're going to enter data into the calculator. The Calc menu is going to be various types of statistical calculations that we're going to be doing through the semester. We'll start that in chapter 3. And then tests, that's going to be different statistical tests that we'll conduct later in the semester when we're doing inference. And so we'll start using these around chapter 9. Anyway, for now, I just want to edit data. So again, I press the Stat button, that brings me to this screen. And to edit the data, I'm going to choose option 1. And I can choose option 1 by either just hitting enter or by pressing the number 1 to choose the first option there. When I press that, I get this screen. So these are called the lists. Your calculator has 6 lists, and each list basically represents a variable. So I want to enter data into the calculator. And specifically, I want to enter this cigarette tax data into my calculator. So first of all, notice that I have data in my calculator already. And so the first thing I want to do is get rid of that data. So to get rid of that data, I can do that a couple of different ways. Like I've got data here in list 2. I could just hit the delete button multiple times to delete it. But if you have a long list of data, you probably don't want to do that. Instead, you can use your arrows and go up so that the name of the list is highlighted. So I'm like L1's highlighted, and you can clear the data by hitting clear and enter, and that clears out that data. Then you have to go through and type it in. And that's the worst part of using your calculator, is that you're going to have to type the data in the calculator. So I would type in 0.425, enter, 2.00, enter, but it's not going to leave the decimals there since it's like $2 is the same as 2. So 2 again, 115, 0.87, 0.84, and so on. Now that's kind of tedious to enter that in. And so before class today, I went ahead and entered data. I entered this data so that I wouldn't have to take time to do it in front of you in class. So I have this data entered in list 6 in my calculator. So before I move on, always double check your data. Make sure that you have it in correctly. If you have any typos, then that's going to mess things up. So like now it would mess up our graph if we have typos in there. Later on, it will mess up calculations. Like if we find an average, if we have any one of these data values wrong, it's going to miscalculate that average. Second thing is, remember where you put your data, which list. So I have my data in list 1, or list 6 rather. I'm going to do second and quit to go back to the home screen. With my data in the calculator, I'm ready to graph a histogram. So I'm assuming that you've used your calculator a little bit before, although maybe not for creating histograms, I suspect. But we do statistical graphs in the same place where we graph equations in algebra. So if I go to y equals, I've already cleared out any equations that I have there, and you should do the same. Make sure that that's empty. You don't have any equations there, because if you do, that can mess up our histogram. So always check, make sure you don't have any equations there. When you're satisfied of that, the way we do statistical graphs is by using the second of the y equals button here. You can see up there in blue, it says stat plot. So that's the different kinds of statistical plots or statistical graphs. So I'm going to hit second and stat plot, and that takes me to this window. Now we can graph up to 3 different statistical plots at the same time if we want to. We're usually not going to want to. We'll just do one at a time. But the first thing I have to do is I have to choose the plot that I'm going to use, and I want to make sure all of the other ones are off. So right now, all 3 of these say off. I'm going to use plot 1, so I'm going to select plot 1 just by hitting enter. The first thing that I'm going to do is turn plot 1 on, and I do that by putting the cursor over the on statement there and hitting enter. So now plot 1 is on. Incidentally, if you look up here at the top, plot 1 is on. See how it's highlighted? Plots 2 and 3 are off. They're not highlighted. If I went and turned on plot 2, then it would be highlighted up here as well. Now, we can do 6 different kinds of graphs, statistical graphs on the calculator. We're going to learn how to do all of these throughout the semester. Right now, what I want to do is a histogram, and so that's indicated by that icon right there. So I'm going to go over and select that icon to tell the calculator I want to do a histogram. The next thing that I have to do is tell the calculator where the data are located. So I put my data in list 6, and I actually already told it that earlier before class. So to put L6 right there, notice that your buttons 1, 2, 3, 4, 5, and 6, the second of those buttons are L1, L2, L3, L4, L5, L6. That's the names of the lists. So if I had my data in list 2, I would hit second and the 2 button right there, and that would put list 2 there. But I have it in list 6, so I'm going to go back to L6. Any questions about any of that? Frequency, you're always going to leave that at 1 if you have raw data. The only way you would change that is if you had data already grouped into classes, which we're never going to have. And then if you have a color graphing calculator, then you can change the color that you want to use. So you can change it to red or black or magenta or green or whatever. I kind of like blue, so I'm going to leave it on blue. If you don't have a color calculator, you don't have to worry about that option. So now I have it set up. I'm ready to graph. The only other thing that I have to do, though, is choose my scale for my graph. So again, I want my classes, I want it to start at 0 and have a class width of 50 cents, and I need to go up to at least $4.50 so that I can see all of the classes. So I'm going to adjust this in the viewing window, and this is the same viewing window that we use for equations in algebra. So I'm going to select window. Now, again, I already set my window earlier when I was looking at this, but I want to step you through this. The two most important things that you have to enter correctly in the calculator for this is the X-min and the X scale. The X-min has to be the lower limit of the first class. So our lower limit of our first class is 0. I have to have X-min as 0. The X scale has to be the class width. We want to use a class width of 50 cents, so I have to have 0.5 for my X scale. Now, the specific value for X max doesn't really matter. I just need to make sure that I'm going to be able to see all of my last class. So X max needs to at least be 4.5 or something bigger. I could make it 5 if I wanted to. As long as it's bigger than the 4.49, that's what matters. The specific value doesn't matter that much, although you certainly wouldn't want to pick like 100 for the X max on this if we're stopping at 449. Likewise, the Y min and the Y max aren't that important. The Y min is going to be how far down you see on the Y axis. So generally, if we're creating a histogram, we don't need to see any further than 0. So 0 makes a good Y min. The Y max doesn't matter so much, other than we want to be able to make sure that we can see the top of the tallest bar in the histogram. So since we have 51 data values, 15 or 20 or 25, something like that would be a good choice for the Y max. Now we may have to adjust it depending on what the graph looks like. So maybe I'll choose Y max of 20. The Y scale doesn't really matter at all, other than that's going to be how often you see a tick mark on the Y axis. So if we're going, say, from like 0 to 200, we might want to change that scale to be like 20 or 50 or something so that you're not seeing a whole bunch of tick marks. Once I have that decided, all I have to do is hit graph, and I get the histogram. So this is the histogram for this data. You do this a few times, you get really pretty quick at it. It's really not that challenging, okay? And again, my tallest bar is going to here, so I could have probably used a lower Y max if I would have wanted to. So I could have probably used like 15 instead of 20 if I would have wanted to. Now here's the cool part. I want to know, what are my frequencies? What are my frequencies? Well, with this in the calculator, if I hit the trace button, when I hit the trace button, I can trace these rectangles. So I'm going to zoom in so you can see the calculator screen a little better. So when I trace this, look what it says over here. It says min equals 0, max is less than 0.5. So that's giving me my first class, essentially. So I'm going from 0 to just under 0.5. 0.5 is where the next class starts. And then this number over here, 7, that's the count. That's the frequency. So there are 7 states whose cigarette tax is somewhere between 0 and 49 cents. Okay, again, that would really be just below 50 cents. So if it was like 49.5 cents, that would be in here. Likewise, if I move over, so this class goes from 0.5 to just less than $1. So that's my second class. And there were 13 of those. So my frequency is 13. And if I continue, 7 is the next frequency, and 8, and 5, and 4, and 4, and 2, and 1. And again, if I added that up, that should add up to be 51, and it will. So I can use the histogram on the calculator to figure out my frequencies, which is kind of nice. Now, the calculator will not find the relative frequencies for me, but with the frequencies calculated, that's not going to be difficult to do. Now, again, we have 51 data values altogether. So if I take 7 divided by 51, that's 0.1372549, blah, blah, blah. So if I round to 4 places, that would be 0.1373 if I round to 4 places. The 5 makes me round up. 13 divided by 51, so that's 0.2549. 7 divided by 51 is going to be 1373 again. 8 divided by 51 is going to be 0.1569. Again, rounding to 4 places. 5 divided by 51 is going to be 0.0980. 4 divided by 51, 0.0784. And the same here. 2 divided by 51, 0.0392. And last but not least, 1 divided by 51, so that is 0.0196. And if I add that up, that should add up to 1. Again, it maybe won't in this case because I had to round, so I may be off in that last place, but it should be really, really close to 1 except for the rounding. I'm not going to go through and add it, but it should be 1 approximately at least. So we've constructed our frequency distribution. We've constructed our relative frequency distribution. We've created our frequency histogram. And I'm not going to draw this out by hand, but we could, now that I have it here, I could transpose that to be by hand. Likewise, with the relative frequency histogram, I'm not going to graph that. It would look the exact same. The only difference would be that the heights of the rectangles would be these relative frequencies instead of the frequencies, but it would have the same shape. Now, if I want to describe the shape, you zoom back out now. So if we want to describe the shape of the distribution, if I look at this histogram on my calculator, so again, our choices are uniform, bell shape, skewed left, skewed right. So in this particular case, the tall bars are over here on the left, and then it kind of trickles off over here on the right side. So we have this tail on the right side. So that means this is skewed to the right. Again, don't be fooled and say skewed left because you're looking for where the tail is when it's skewed. So this is skewed to the right. The worst part of using the calculator, in my opinion, is having to type the data into the calculator. So I want to show you how to use StatCrunch. So I've shown you before how to get data into StatCrunch. You can type it in or you can load it in, right? So you can load it in like from the exercises in my lab, for example, that you're working on. So before class, I went ahead and opened this data in StatCrunch. So this first column here, which is called VAR1, has that cigarette tax data in it. And I want to create a frequency distribution. I want to create a relative frequency distribution, and I want to create a histogram. If I were to be totally honest with you, I'm going to show you how to create the distributions, the tables. But to be totally honest with you, I really wouldn't do that. I would do exactly what I just did with the histogram, and I would use the histogram to determine my frequency distribution and relative frequency distribution. So anyway, if I want to create a distribution here in StatCrunch, I'm going to go to data, and then I'm going to select bin, B-I-N, and I get this window that comes up. So data and bin. Now, the next thing that I have to do is choose where the data is located. In this particular case, it's located in this column called var1. And then I have to define my bins. Okay, I got to give you this speech again. Statistics is a relatively young science, right? And so terminology and techniques are still evolving in statistics. So we've been using the term class. We created classes for our frequency distribution. Another common term that's used is bins, B-I-N-S. So instead of classes, we could call it bins. And StatCrunch uses that terminology. So when it says define the bins here, we're defining the classes. Now, if you don't want to define your own bins, you can let StatCrunch do it for you. It will automatically choose them. The only trouble with that is it may not be what you want. So as a general rule, you're going to want to choose your bins yourself. So I'm going to generally select this option. I'm going to start at 0. That's going to be the lower limit of my first class. And then my class width, which StatCrunch calls bin width, is going to be 50 cents. And you're going to want the bin edges to include the left endpoint, okay, not the right endpoint. So for example, like for the second class, 50 cents is in the second class, not the first class. If I choose include the right endpoint, then 50 cents would go into the first class instead of the second class. As a general rule, we don't want to do that. If I say compute, StatCrunch puts in all of these bins in the next column over. Now, what this is saying is this: the 42.5 cents, the first data value, goes in the first bin from 0 to just before 50 cents. And then the $2 goes in the $2 to $2.50 bin, except it's really just before the $2.50 bin, and so on. So what it's doing is it's, with what we just created, StatCrunch is figuring out which bin each data value goes into, and it puts it in this other column. Now, if I want to go about creating a frequency table or a relative frequency table, what I'm actually going to do is I'm going to create the table using this bin data that we just found. So I'm going to go to Stat, and I'm going to go to Tables, and I'm going to choose a frequency table, and that gives me this window. Now what I'm going to do is I'm going to select the name of this column that has all the bins in it. So in this case, StatCrunch called that bin and then var1 in parentheses. So that's bins for the var1 variable. And then by default, these are selected with frequency and relative frequency. It's going to be in ascending order. So it's going to put the first bin, then the second bin, then the third, and so on. And all I have to do now is say compute, and it shows me the frequency and the relative frequency table here. So there are 7 data values from 0 to just before 50 cents. There are 13 data values from 50 cents to just before $1. There's 7 data values from $1 to just before $1.50, and so on. And then you can see the relative frequencies here as well. So StatCrunch does have the capability of making this frequency and relative frequency distribution. Again, it's perfectly fine. There's nothing horrible about it. It's just a little awkward that you have to put the bins here, and really you're creating the table from this. So again, nothing wrong with it. You can do that. And this gives us the answers to part A and B on the handout for this problem. So we have the frequency distribution and we have the relative frequency distribution. But truthfully, I don't think it's really necessary to create this table if we're going to use StatCrunch. Instead, I'll leave that open, but I'm going to go straight to graph and I'm going to create a histogram. So I'm going to go to graph and histogram and select that. And that gives me this window, which is more intuitive, I think. So the first thing I have to do is select the column that has our data in it, which is var 1. I have to choose the type of histogram I want. So I could do a frequency histogram, or I could do a relative frequency histogram, or I could do a density histogram. We'll never use density. We'll either do frequency or relative frequency. So I'll leave that frequency for now. Now, the bins, I can tell StatCrunch where I want to start the first bin and what the bin width is going to be. Now, again, they see the words optional there because StatCrunch will do that for me. Again, it just may not choose the ones that I want. So usually I'm going to want to pick those myself. So I'm going to start the first class at 0 and then use a class width of 50 cents. Like with bar graphs, I like to select this option right here to put the value above the bar. And that's pretty much it. If I say compute, StatCrunch gives me this histogram. And so if I point at the first bar here, it tells me the frequency 7, which I can also see above the bar. But moreover, it tells me that the first class is going from 0 to just before 0.5 or 50 cents. Notice that it's using interval notation. So it puts a bracket on the 0 indicating zeros included inside that class. And then it puts a parenthesis on the 0.5 side. So really we're going to just before 50 cents. 50 cents itself goes in the next class and so on. So personally, I find it easiest to just create the histogram, and then I can use that to create my frequency table. If I want a relative frequency histogram, all I have to do is change this to be relative frequency and recompute, and then that gives me the relative frequency histogram. Now, in this case, when I have the values above the bar, it rounds that to 2 decimal places. If you need it to be more than 2 decimal places, if you point to the bar, you can see that relative frequency is really 0.1372549 and so on. So this relative frequency is 0.2549 and so on. So again, if you practice using StatCrunch or the calculator for that matter, either one, it will speed things up for you. Instead of you having to tediously go through and count all the data values, it will do that for you and calculate the relative frequencies and so on. And again, I can clearly see that this is skewed right. So we have completed our cigarette tax example.